don't know if it's picking that up, but there's actually two there also. Yeah, there you go. You can see them. Heavy zoom. It's on a higher frequency. Bidirectional push-pull. Same spark gap. When the incident frequency is provided, the spark gap, static spark gaps will oscillate at harmonic intervals of the incident frequency, which is why we're limited to 60 hertz to multiples of that based on the power output. So harmonic distortion occurs from the higher the voltage, and we get a third harmonic and a fifth harmonic, and then a weird distorted seventh that occurs. I got that unhooked. Only works when there's an imbalance in the series distributed capacitance, because this is a 10 nanofarad and this is a 5 microfarad. So drastically different. 2 5s doesn't work. 2 10s doesn't work. I tried like a 450 in there, nanofarad, and some different ones, and seems to be the smaller the better over there, but the larger the better over here. And anyway, at some point, if I hook this spark gap up to operate, now the original one no longer arcs at this frequency, but we do get some distortion in there, so some fluctuations in the arcing at different harmonics. But as you can see, it powers. It's too light in here for this, but it powers the bulb. I'm using the tube amp bias control, so which is the increasing the plate current that's pulsing the primary of this toroid here. I can get those distortions to tame out if I just bring it till it comes on, and then the actual input, the millivolt level gain, really controls when those harmonics start to occur. So there's a tiny fine threshold that's like the difference between 1 or 2 millivolts or more, to where I get the incident frequency and I don't know if you could hear it, but there's an octave coming in. There's the full octave, but there's so much distortion that occurs with very slight variation. But as you can see, let me shut this off for a second. Move this back to the spark gap. It will find some kind of unity, in a sense, once the fluctuations start to become more normalized. So I'll introduce a disruption, like changing the frequencies or something, and you can hear, where's it? You can hear a harmonic, but it's also has dropouts to the low frequency, and that's replicated in the series capacitance kind of setup here. This is that would be my hairpin inductor, the primary of that. So it builds up, and it's almost the beat frequency energy that's driving that, because it's only when the disruptions occur, obviously, that their max surge of power goes through there and can affect the light. I can switch to the other side of the capacitor. Depending on where I move the spark gap, it's technically off of the secondary in parallel. This one is, but then this one here, I'm jumping from that side to either side of this larger capacitor and just getting some different results. So here, we get a higher harmonic happening, but on this side, the harmonic distortion doesn't really occur. It stays at the octave, and initially the current flow state is the reactive balance, I guess you could say, is inefficient until it runs for a while, and then things balance. Now we're dealing with dielectric breakdown of air here, which is making this seem intermittent, but you can visibly see the power increase that happens over time as sort of a parametric standing wave or some reflective or reactive power is building up. Where it starts actuating the coil. So this is a very tiny amount of wraps here. I don't know what's normal for like a ZVS or whatever, but I'm only running this in unipolar fashion with what is more of like a peak-to-peak output here, reading around 130 volts because of the spark gap, but this can go up to about 600 volts depending on my duty cycle and whether or not I have these other spark gaps in here. Pretty cool, huh? Current limiter. This is voltage on the secondary right now. If I bring the bias all the way down, it goes up some. As soon as I start to drive the tubes a little harder. But if I kill the input, which is just the millivolt signal, the voltage on that all the way over there on that toroid secondary is instantly affected because of the conduction that changes ever so sensitively from this fine high performance high gain detector preamp. Very interesting. So what's really required then is what's known as interstage coupling of the power output tube stage and the load stage. In this case, a series distributed capacitance circuit with an inductor here that in the center that sees the standing wave displacement currents that are going on here and is able to induce that secondary to some extent. It's a crappy primary wrap, but I am very hopeful for this ever so gracious to Chris Burak for making that and sending it to me to play with. We will get it.